Now, how to calculate the system capacity? So you should know a little bit about your system before working in R. When using R with larger data sets, it may stop R from running itself when the capacity is overused. You should know how much memory is available, which is the RAM, random access memory of your system, to compute exactly, not just exactly, just a rough calculation of how much memory will be needed for our programming to run, and what other applications are in use. You can just use the task manager and you can see the processes in it, and who are the other users logged into the system, and what operating system that your system uses, and is the OS 32 or 64-bit. Currently it's a 64-bit OS, that's why we are working with the 64-bit version of the R program. Now, how to compute that? There is a very small calculation regarding this memory requirements. So let's say you have a data frame with like 15 lakh rows and 120 columns. And let's say all are numeric data for simplicity. And you can just estimate how much memory will be required to store this data frame into an R data set. Let's say for a single character or a numeric or any kind of the atomic object that inserts into uh, a data set will occupy 8 bytes. Let's say for numeric it's 8 bytes, and if you have some 15 lakh rows, so and which have 120 columns and each will have 8 bytes per numeric, so it will be 8 into 120 into 15 lakh, which will give you 144 into 10 to the power 7 bytes. So let's say there are like 220 bytes per MB, and like your data set will lead to 1.34 GB, which is approximately 1374 MB. So this will be the memory requirement for working on this set of 15 lakh rows of data. Now if you have 2 GB RAM capacity, you can directly go with it, which will be a little slower. But if you have a 4 GB RAM or more than that, this will be much faster. Moving on, we are going to move into textual formats. Now dump and deput are used in our programming, and which are very useful because the resulting textual format is editable, and in the case of corruption it is like potentially recoverable. So unlike writing out a table or a CSV file, dump and deput or preserve the metadata. Metadata is nothing but the data about data. I mean how the data is stored. You have a data, let's say you have same the 15 lakh rows and 120 columns. This metadata will tell you how these exist in the data set. So deput and dump are these functions which will help you write the data set into an external file. So again, this metadata should be preserved, so that another user, let's say some other user comes in and writes a data set, he doesn't have to specify it all over again. So again, textual formats, they work much better with version control programs like Subversion or Git, which when when you create open source programs, you need to specify the version and the subversion which you create, and this will be useful to track changes between different versions meaningfully in text files. And textual formats can be longer lived. If there is corruption somewhere in the file, it is easier to fix it. Textual formats adhere to the Unix philosophy. You can search for this Unix philosophy in official GNU pages, where you get Unix data about Unix philosophy and all. And the downside of textual format, it's not very space efficient. Moving on. So how to use this deput R objects? to extract OR objects. Let's say there is a OR object and you want to deparse it using dput and read it back using a dget. Dget is again, it's similar to read.table, only here the difference is you are just reading a data, that's all. Let's follow this small example. Let's create a data frame with a integer and a character. Control L, which will clear your screen. Let's create a data frame with a equal to 1, which is a numeric, and b equal to a, which is your character. Now this data frame is created. Now what does dput y tells you? So it tells you the structure of every character and the metadata associated with it. There are one numeric and one character, and here as you can see the metadata also gets stored in dput of y. Structure of list a equal to 1, b equal to structure 1l, and dot label equal to a, class is a factor for a, and dot names of c. This is the metadata which will be used when you want to know about the data that is being. Here the data frame is very small, so this data doesn't make much sense, but when you have a larger data set, this will make much more sense. Now this file can be moved into, let's say, use this dput of function, and you can move y into a file called, let's say, y dot with an r extension. Now you see that there is a R file created with y, and you can open it with a notepad, and you will see that structure, the same thing gets extracted into this. So this is what dput is useful. It gives the structure of the data frame or any kind of data, and when you move into a specific file, it will help you store. This information is useful when you create multiple versions for a program that you are creating, and this will help you track what are the changes in each of the versions. Now the same way you can move the data within y.r into a file. Let's say you want to create the same thing. New.y. Using the dget function, you can specify the file name and finish it. Now if you want to display new.y, you will find that 1 and a in columns a and b. So this is what dput and dget are useful for. Now moving on, what is dump? So dump is the same way as dput, but here you can use dump to deparse multiple objects and read back in using source. The same way dget works. Dget and dput always go together. The same way dump and source go together.